Okay, picking up right where we left off, we're gonna have some just word problems and just more time to practice this stuff. So we got a railroad crossing problem. So the arm's 20 feet long and is stuck at an angle elevation of 35 degrees. So that's something we're going to talk about in the future. But angle elevation is you straight out, then up. All right, we're going to find the length of y. All right, so in this particular problem, reference angle, that's the adjacent side. 20 is the hypotenuse because it's opposite the right angle. So again, maybe it's a good habit that you guys need to write this down a lot. So, ka, toa. Which trig functions uses a and h? That's cosine. So we're gonna have cosine of 35 degrees equals adjacent, which is y, over hypotenuse, which is 20. If we can get this blue part, we're going to be in good shape. Cross multiply, y equals 20 cosine 35. And from here, it's just plugging it into the calculator. So y is going to be 16.4. All right. So what's really cool about right triangles, the all-powerful right triangles, we have so much things in our tool belt about right triangles. We have the distance formula, we have Pythagorean theorem, now we have trig. All right, to find x, if we wanted to find x, we could use Pythagorean theorem. Or we could use trig. And at this point, using trig, we could use sine, which is what I would probably do, or you could even use tangent. All right, so we got all these methods to find x. We're not going to find x, the problem didn't tell us to, but just look how great right triangles are. We know so much about them. They're very powerful shapes. In my opinion, the most important shape in the universe. For those who are Marvel fans, you might say the Tesseract is the most important shape. Nonetheless, let's do the famous lighthouse problem. All right, here in the lighthouse, we'll draw. Here's another de Shetler sighting. There's Mr. de Shetler. He's wearing a gray suit. He looks snazzy. We'll give him a Derby blue tie. He's wearing a purple hat. That's Mr. de Shetler. He's standing at the top of the lighthouse looking out for boats. We're going to find the height of the lighthouse to the nearest foot. And again, I'm going to write so, ka, toa, right there. All right, we have this reference angle, 62. 100 feet, that's the adjacent side. H, the height is the opposite side. All right, it does not touch. So which one uses adjacent and opposite? Well, that's toa. And then in the real world, toa or tangent is probably the most useful because you're typically going to know the horizontal and vertical heights of things. Slant height, that's a little bit more difficult. They're all important in real life. I'd say tangent in terms of this stuff is probably the most common. Opposite over adjacent. Put it over 1, cross multiply, h equals 100 tan 62. 100 tan 62. Have to plug that into my calculator. And the height is about 188.1. Boom, nailed it. All right, next problem. A strange man is kayaking in a lake and observing two geese. He is staring at one of them at a 50-degree angle of elevation, and his eyes are 4 feet above the water. He knows that the geese are a horizontal distance of 30 feet away. How high above the water is the goose's head? Fun fact, true story, this is me. not the goose, the kayaker. This is a live picture. I was chasing geese in the kayak and then they escaped via flight. Anywho, this is a really good problem right here. Alright, we need to figure out how high is this goose's head above the water. Well, let's look at this picture I drew for you guys. We got this reference angle, 30 feet's the adjacent side, and then opposite again. So we got another tangent problem. Alright, that pesky tangent that I said it was so useful in the real world. Alright, so let's just find this height right here. Tangent of 50 equals opposite over adjacent, which is 30, over 1, cross multiply, opposite equals 30, tan 50, 30, tan 50, enter. So the opposite side's about 35.6. Alright, now the height of the goose's head, this total height is just going to be 39.6 because we had to add the 4 feet, and that's the answer. Alright, we'll do these extra practice problems in the next video. Stay tuned.